double integral. Yes, now? Yeah. And today we are going to discuss about that. And it is now it's come to today we are going to discuss about the triple integration. Okay, so last class we discussed about that double integration, and today we are going to that the triple integrations. So last class that is only in x-axis and y-axis, and we are using the dx and dy. Yes, now there's additional one more axis, z-axis, and this is in 3D dimension. Now that we can write as a dz. So dx, dy, and dz. Okay. So in the double integration, so when you are doing with x, so when you are doing that integration with respect to x, so when you are doing that integration with respect to x, so we take as y as a what is a
Constant.
yeah, very good. So y we are as taking as a constant. Okay, and similarly when you are doing with respect to y, so we are taking that x as a constant. Okay. Now same similarly in the triple integral, so dx, dy, and dz. So when you are doing the integration with respect to x, so with respect to x, so here y comma z are become what is a
Constants.
constants. It's become to constants. Okay. So when you are doing the integration with respect to y, then this 2 are become what is that? X comma z are become constant. So when you are doing that integration with respect to z, then x comma y r is become to the constant. So this is the triple integration. In double integration, we are using that only in xy plane. This is x-axis and this is the y-axis. That is in 2D dimension. Now here that is x, y, and one more is a z. X, Y, Z plane. This is actually Z is like state, but we cannot draw no. So that's why we are writing to the here. X-axis, Y-axis, Z-axis. Same thing here when you are doing with integration with respect to x, and we are taking y comma z as a constant, and similarly when we are doing that integration with respect to x, y and x comma z as a constant, and when you are doing the integration with respect to z and x comma y as a constant. Okay, let's see one problem. So evaluate so 0 to 1, 0 to 2, and 0 to 3, x, y, this is y and z, dx, dy, and dz. So evaluate that integral 0 to 3, 0 to 2, 0 to 1, x, y, z, and dx, dy, dz. Okay. Now see the solution. So this is dx, dy, dz, no? So dx, no? So this is become to the x limits, and this is a y limits, and this is a z limits. Okay. Now see the solution. So first we are doing with x. So 0, 3 is outside and 0 to 2 is also outside. And the inside 0 to 1 x. And here yz is become what is that? Constant. So we have to write that yz and dy dz. And now tell me what is the x dx integration?
X square by
Yes, x square by 2. And that limits are 0 to 1. Yes, sir? And yz dy dz is outside. Okay. Now this is x square y by 2. No? Now let's see. Now apply the limits. That is become what is that? 1 by 2. So that integration of 0 to 3. Now we have to do the integration with respect to y. 0 to 2 y dy and outside dz. And already here if you are substituting there, what is that? In place of x we have to substitute 1. So what we are getting? What we are getting? 1 by 2 yz dy dz. Okay, no? So yz, so 1 by 2 is there, no? So we have to write that 1 by 2. 0 to 3, 1 by 2. Now what is the integration of y dy, ma? What is the integration of y dy?
Y square by 2.
Y square by 2. Y square by 2. And apply the limit 0 to 2. So what we are getting? 0 to 3 and 1 by 2. Y square means in place of y we have to substitute 2. That is become 4 square, 4 by 2. So that is become 2. And here additional what is that? Z is also there. Z. So 2z into dz. 2 get cancelled. Yes, na? And next. Zero to 3 integrate z dz. So that is become z square by 2 and apply the limit 0 to 3. So what is the final answer, Nana?
9 by 2.
9. Yes, no? Now this is a concept. So when you are doing with respect to x, y as a constant, and when you are doing respect to the y and z is common constant. When you are doing the y, x and z is a constant, and when you are doing the integration with the z, then x comma y is a constant. So this type of problems coming in the examination now. Okay. So let we go to that. Just wait, I'll share the PDF. I'm not getting that. Yes. Please be online. No, just I will download that. We'll do one more problem in the here only. Yeah. So the next one. So evaluate 0 to 2, 0 to 3, and 0 to 4. X plus y plus z into dx, dy, dz. Okay. Yeah. So first 0 to 2 and 0 to 3 outside. So now that inside 0 to 4, x plus y plus z, we are doing with dx. Initially we are doing that dx and dy dz. Now tell me 0 to 2 and 0 to 3. Now what will happen this integration? X into dx.
X square by 2.
X square by 2 plus
Yx.
y into dx, yx, and z into dx,
Zx.
zx, and dy dz as it is. Now apply the limits. What is that? 0 to 4. Okay. And 0 to 2 and 0 to 3. Now we have to substitute 4 square by 2. 4 square means 16. 16 by 2, 8. Plus 4 into y plus 4 into z into what is that? Dy dz. And similarly, we have to do with the integration with y. Again, we have to apply the limit 0 and 3. And finally, we have to do the integration with z and apply the limit 0, comma 2. Okay, so this is a procedure. Wait, Mark, share the PDF. It's not getting. Please be online. This is all are finished in the last class. Change of order. Yeah. And polar coordinates is also there. No? Just I will complete it after this. Triple integration, I will complete it, that one. After the triple integration, we'll go to the polar coordinates in double integration. Okay. So this is the triple integration. Okay. So the triple integration can be defined as in the same way of the double integration. If f is a continuous function of x comma y comma z over the region or is enclosed by the surface, then the volume enclosed by the region. So this here dv equal to the volume. The dv we can define what is that? Dx, dy and dz. In the double integration, that is ds. So ds means is nothing to dx, dy, and dv means dx, dy, dz. Okay. Now see here. See the first problem. So already here is there. Already just now we discussed now. To evaluate the triple integrations, first we integration with x and treating y comma z as a constant. Okay. And next, again, if you are doing that to y, we are taking the z as a constant. And finally, we are doing that integration with respect to the z and apply the limits of z1 and z2. So this is the procedure is there. See the first problem. So evaluate that integration of x, y, z, dx, dy, dz and taken as the positive operand of the sphere. This is a sphere equation. What is a circle equation, Nana? What is a circle equation? Equation to the circle. What is the equation to the circle? Unnarama GK.
Sir,
What is the equation to the circle?
circle x square plus a square is equal to r square
X square.
plus a square is equal to r square.
A square కాదు నాన్న. X square plus y square
Y
equal to
square, okay, sir. Y square. A square.
and sphere. This is a standard form. So what is the difference between circle and sphere?
Circle is two-dimensional figure.
Very good.
Sphere is three-dimensional figure.
Yes. So 2D that is a circle. When it is come to 3D that is big to the sphere.
నేను క్యాప్ ఏది కృతి ఉండరా నేను వస్తా ఉన్నా ఏ కృతి క్యాప్ ఏది
Okay.
క్యాప్ ఏది?
Now we'll go to problem more. Hello. Oppo F11.
వాడుంటే తీసుకురా కృతి
Oppo. మా డిస్టర్బ్ గా ఉంది. Now we'll go to the first problem. X, y, z, dx, dy, dz in the sphere that x square plus y square plus z square equal to a square. Yeah. So initially we need what is that? Limits. First of all, we need the limits. Yes, na? See here. How we can take that limits? So x square plus y square plus z square equal to a square. From here, z square equal we can write what is Amma? Z square equal we can write?
A square minus x square minus y square.
Yes. So z equal to
Under root of
a square minus x square minus y square. So therefore the z limits are 0 to this under root of a square minus x square minus y square. Next, for the y limits we put z equal to 0. So when we are putting the z equal 0 and we are getting what is that x square plus y square equal to a square. So y equal to become what is under root of a square minus x square. See for the x limits. See ma, I'm telling, listen. For y limits, we put z equal to 0. For x limits, we have to put y equal to 0 and similarly the z equal to 0. So you have to apply this all the formulas, all the problem. Okay. When we need the y limits means just we have to put z equal 0. And when we need the x limits means we have to put y equal 0 and z equal 0. So that we are getting what is that? This is a z limits and this is a x limits and this is a y limits. Okay. Now first z into dz. See here z into dz and xy right outside. And now z into dz, that is become what is amma? Here it put the wrong ma. This is dz, dx, dy, dz. Z into dz. What is amma? Z square by 2 na. And what are the limits? 0 to under root of a square minus x square minus y square. Okay. And again we have to integration with respect to the y. Now we have to simplify. That is become a square y and x square y minus y square into x. Next here a square xy. So a square x is a constant and integration of y dy, that is become what is that? Y square by 2. Oh, here is the term. And next x square y. So already here x is there. X into x square x cube and y integration is become y square by 2. And the final thing y into y square, that is become y cube. So y cube, that is become y power of 4 by 4. And we have to apply the limits 0 to under root of a square minus x square. So we are getting this one. Again we have to simplification. Again at the end of the we have to do what is my integration with integration with at the end.
X.
Again we substitute that all the formulas. Substitute all the limits. What are the limits? 0 to a. Then we are getting that answer a power of 6 by 48. So this is dz, not dr. This is the dz. Understood, ma?
Yes, sir.
Clear, and it is important problem. Next. If the radius of the base and height of the right circular cone A and H, base is A and altitude of the right circular cone, that is what is that? H, A comma H. So then express it as a value as a triple integration and evaluate using the cylindrical coordinates. So he's asking to find that volume of the right circular cone with base is the A and the height is will be H, and using that cylindrical coordinate, using that evaluate cylinder coordinate. Now let's see here. See, taking r comma theta comma z is the coordinates, then the equation of the cone is become, see here, z by r equal to h by a, or from here we can write z equal to rh by a. Now by the consider that small elementary volumes r dr d theta dz, its volume can be evaluated. So here dx dy dz. Yes, no? So this is 3D dimension, and we are taking that the volume is what is that? R dr d theta and dz. So r dr d theta dz. Now these are the z limits, and that radius is nothing to what is that? They already given that a. So 0 to a, and that d theta means that complete degrees. So degrees we are taking that 0 to 2 pi. So 0 to 2 pi శ్రీలేఖ అమ్మా ఆడియో అవుతుందా, ఆడియబుల్ అవుతుందా?
No, sir. It's not audible.
అమ్మా yeah. So first we are doing that integration with respect to z. So z here nothing will be there, na? So that 1 into dz. So 1 into dz is nothing to that z, and apply the limits from z to rh by a. So that is become z minus rh by a. And next we have to do the integration with the r dr. So let's see here, hr minus r square h by a, the integration. So that is become hr integration, h will be right outside, that is become r dr integration r square by 2, and r square integration r cube by 3. Okay. And next apply the limits 0 to a. And the head of the n we can write d theta. D theta means we have to do that integration with respect to theta. So when respect to theta and apply it to the limits, what are the limits? 0 to 2 pi. And finally we are getting what is that? 1 by 3 pi a square h. 1 by 3 pi r square h. What is this one?
Volume of the sphere.
Volume of the sphere, Kona.
So
Volume of the sphere 4 by 3 pi r cube, ma.
cone.
Cone, that is 1 by 3 pi r square h. So here they're given the radius is a now. So then we are getting what is that? 1 by 3 pi a square h. Okay. Next. Find the volume of the space. It is bounded by the sphere x square plus y square plus z square equal to a square. So in the same thing, so we are taking the coordinates, then r square plus z square equal to a square, and that the volume is become r dr d theta and dz. Now here substitute is there. R dz dr d theta and the z limit r square plus z square equal to a square. Then the z square is become r square minus a square. So z is become under root of r square minus a square. So that is, sorry, a square minus r square. Sorry, a square minus r square. So the z limits are plus under root of a square minus r square and minus under root of a square minus r square. So again we apply to the limits. So finally we are getting that under root of a square minus r square r dr d theta. Now we have to do that integration with respect to the r. But here what is that? Under root of a square minus r square into r is there. So let's take r square equal to capital R. When we are doing the differentiation, that is become 2r dr equal to capital dr. So in place of r dr we can write capital dr by 2. So that will become the next here mark, that integration part. Now we have to do the integration with respect to the r. So we are taking that this r square equal to capital R. So when we are doing the differentiation, r square is become 2r and dr equal to capital dr. Okay. Now taking r square equal to r. This is a square minus r whole power of 3 by 2 by 3 by 2. Why? Because here under root of is there, no? So under root of a square minus r is there. This we can write a square minus r whole power of 1 by 2. So integration of x power of n dx. What will happen, ma?
X to the power of n plus 1 by n plus 1.
X power of n plus 1 by n plus 1. So here 1 by 2 plus 1 by 1 by 2 plus 1. So that is become 3 by 2. 3 by 2, 3 by 2. And at the end of the, and we have to substitute the limit 0 to a square. And at the end of, we have to do the differentiation, integration with d theta, with respect to theta. Then we are getting 4 by 3 pi a cube. So this is the volume of the, what is that?
Sphere.
Sphere. And volume of the cone?
1 by 3 pi r square h.
1 by 3 pi r square h. Yes. So we proved like. Okay. And in the yesterday class, we discuss only up to change of order. Yeah. So we discuss up to the change of the order. Now we have to evaluation the double integration using the polar coordinates. What are the polar coordinates of? Idea లేదా?
No, sir.
That x equal to a cos theta and y equal to a sin. These are the polar x square plus y square. What is the name of the equation? Idea లేదా? Y square equal to 4ax.
Sir, your voice is not visible, sir.
Y square equal to 4ax. Now it is visible. Hello.
Sir?
Now it is visible, ma?
Yeah, yes, sir.
Y square equal to 4ax. What is the name of the equation? Idea లేదా?
No, sir.
This is parabola, ma.
Yes, sir. Okay, sir.
Yes, na?
Yes,
What is
sir.
the parametric equation? X equal to, see, x equal to 8 square and y equal to 2/8. These are the parametric equation, and in the same way, polar coordinates for the sphere means x equal to a cos theta and y equal to a sin theta. Okay. Now evaluation the double integration. See, in dx dy we are completely changed. The last problem, what is that? This is, we are changing that order of the integration. That means we are changing to the limits. But here we are changing to what is that? Direct variable. What is that? In place of dx dy, we are changing to what is that? Du dv. We are not changing to the limits. Here we are changing to the completely that variable. In place of dx dy, we are changing to the du dv. So what is the formula means? Let's see here. Double integration of f of x comma y dx dy equal to the double integration of r f of phi of u comma v and j of u comma v, and this is the norm of j and du dv. So what is the norm of j means? This is here. So that is dou x by dou u and dou y by dou u and dou x by dou v minus dou y by dou u. This is the value of j of u comma v. Here is there this value. Suppose it is in the polar coordinates form. and this is the term will become dou x dou r dou y dou r dou x dou theta and dou y dou theta. That's we can write directly we can write in the when it is polar coordinates. This j value we can write is what is that r. If there is a normal form, then we have to find that j value. Jacobian they are telling. So how it is the formula means? See, listen. Dou x by dou u and dou y by dou u. That is dou x by dou v and dou y by dou. So we have to find the determinant of this matrix. How? Like this. So dou x by dou u into dou y by dou v minus dou x by dou v into dou y by dou. This is the formula. Okay, if they are giving in polar coordinates, we are changing onto the polar coordinates and directly that Jacobian that we can write r. Directly we can write that is the r. Yeah. So this is when we are changing into polar form. F of r comma theta dr d theta. See that then here the one more example problem is there. So evaluate the double integration of under root of a square minus x square minus y square dx dy over the upper half of the circle x square minus ax plus y square equal to 0. Okay. Now let's take this. We are changing into polar form. That x equal to a cos theta and y equal to a sin theta. When the theta is in between 0 to 2 pi. Now the double integration under root of a square minus x square plus y square that we can write r square. So that is become under root of a square minus r square dx dy we can write what is that r dr d theta. And that or the values changing from 0 to a cos theta here is that. And the theta is from 0 to pi. Same last just we now discuss now. Let's take this r square equal to capital R. Then r square derivation is become 2r dr equal to capital dr. And when you are doing that integration, we are getting minus 1 by 3 a square minus r square whole power of 3 by 2. And 0 to the limits, we have to apply a cos theta 0. And we are getting 0 to pi by 2 1 minus sin cube theta d theta. See here, integration of 1 minus sin cube theta d theta. This integration we need to find. 1 into d theta that we can write d theta, no problem. But sin cube theta, is there any formula is there? Is there any sin cube theta formula? Hello? Sin cube theta formula. No idea.
No ideas.
Sin 3 theta formula. Three sin theta minus 4 sin cube theta. Yes, na?
Yes, sir.
So from here we can write sin cube theta equal to what we can write? Sin 3 theta minus 3 Sin cube theta. Sin 3 theta formula is 3 sin theta minus 4 sin cube theta. So from here we can write sin cube theta equal. What we can write the sin cube theta? Sin. If you are sending to this side, 3 sin theta minus sin
Sin
3
theta by
theta.
4.
So here in place of sin cube theta, we have to substitute this one and apply the integration. Sin theta integration, we know that cos theta, and sin 3 theta integration, sorry, minus 3 cos theta. Sin theta integration is minus cos theta. Sin 3 theta integration minus 3 minus cos 3 theta by 3. Okay, ma? And apply to the limits 0 to pi by. So here he wrote the direct answer, but this is a simplification. 1 d theta directly we are getting the theta, no problem. But when you are doing the integration of sin cube theta means, and this is the procedure. Sin cube theta equal to, we can write 3 sin theta minus sin 3 theta by 4 and apply to the limits. Okay, ma?
Okay, sir.
Is it clear that problem?
Okay, sir. Clear.
Yeah. Evaluate by changing the polar coordinates. So there is dx dy is there, and we have to changing in form of r comma theta. So this is the function of f of x comma y, and we have to changing in the function of r comma theta. So how we are changing that? Just now we learning the, so dx dy. So dx dy we have to write what is that? R dr d theta. Okay, r dr d theta, and x square plus y square equal to that is r. So already here r dr d theta, no, r will be there, no, that is become r cube dr d theta. R square into r dr d theta, that is become r cube dr d theta. And the limits are 0 to 2a cos theta. This is the radius limits 0 to, that r limits are, what is that? That r limits are 0 to 2a cos theta, and the theta limits are 0 to pi by. First r cube dr, that is become r power of 4 by 4. So next substitute r equal to 2a cos theta, that is become 16a power of 4 cos power of 4 d theta. Yeah, cos power of 4 theta integration we need to find. What is the formula? 4 theta. ఐడియా ఉందా ఏదైనా ఫార్ములా? Sixteen a power of 4 right outside. What is the 4 factorial, ma? Integration of cos power of 4 d theta. అట్లా ఐడియా ఉందమ్మా? విగ్రహం ఇంటిగ్రేషన్ లో వస్తుంది. Formula. Cos power of 4 ni we can write cos square theta into cos square theta. And cos square theta we have to write 1 plus cos 2 theta by 2. So completely that is going. So I'm telling that the formula of cos power of 4 d theta is 3 by 8 plus cos 2x by 2 plus cos 4x by 8. So this is the formula cos power of 4 theta and apply to the limits 0 to pi by. Here theta is there, no? So that is become cos 2 theta by 2 and cos 4 theta by 8 and apply to the limit 0 to pi by. Then we are getting that this one pi a power of 4 by 4. ఇది రాసుకోండి ఫార్ములా 3 by 8 plus cos 2x 2 theta by 2 plus cos 4 theta. Cos 4 theta by 8. This is the integration of cos power of 4 theta dt and apply to the limit 0 to pi by. What is the cos 90 value?
0, sir.
Cos 0 value
1.
1. So we have to apply to the limits 0 to pi by. So already here 16 is outside is there. So when you are applying to the cos 90, the completely will become 0. Next we have to apply in place of theta 0. Then we are getting 3 by 8. Next 1 by 2 plus 1 by 8. So after the simplification, when we are getting 3 pi a power of 4 by 4. Okay, ma? Find the area of the ellipse. Same. Required area is 4 into area of A1. This is also important. Find the area enclosed by ellipse. 4 into area of 0 OAB. This part. X limits are we are taking 0 to A and the Y limits are see x square by A square plus Y square by B square equal to 1. So from here y square by b square equal to we can write 1 minus x square by a, that is become a square minus x square by a square, and y equal to we can write b into under root of 1 minus x square by a square. So these are the y limits and these are the x limits. X limits are 0 to a, this is x equal to, and that y equal to 0 to b into 1 minus x square by a square. So area formula is that is dx dy. area equal to, that is integral of dx dy. And the remember thing, the volume formula is integration of dx, dy and dz. This is only the small part area, that is pi AB by 4. This is area only. This part area is pi AB by 4. But we need the 4 parts, no? So that is become 4 into pi AB by 4. 4 get cancelled. Here is there. So we are getting pi AB. So the area of the ellipse is pi AB. Clear, ma? In the double integration dx dy, yeah, equal to that volume equal to the double integration. Okay? And here respect to x, y as a constant. Doing that integration with respect to next, this is the first step. Next step, with respect to y, so z has become what is that? Constant. So at the final, we have to do that integration with respect to that z. Okay, ma, is it clear? Clear now? If you are see the previous paper, the double integration problems will be there. Clear for this topic?
Yes, sir. Clear.
Dx dy is there, no? When you are changing to the polar form, dx dy place we are writing r dr d theta. Remember, r dr d, changing the variable from dx comma dy from x comma y to polar coordinates r comma theta, and we are writing the dx dy equal to r dr. So when the function f of x comma y, we are changing to the variable u comma v. So we had to apply that Jacobian of du dv. So what is the j value means? This is a j value. Dou x by dou u, dou y by dou u, and dou x by dou v minus dou y by dou. This is the determinant. When the dx dy we are changing. So in dx dy we can write the norm of j into du dv. But in when you are asked into polar coordinates, directly we can write dx dy equal to r dv. That's good. So this is the change of variable. Yeah. This is the topic is ended. Huh? Check it out. And mostly solve the example problems in the